Okay, good morning. This is Professor David J. De Los Reyes. My topic for this morning it's March 22, 2023. The time is 6:36 a.m. Okay, my topic is just a refresher course on integral calculus. Okay, okay, let's proceed. We are given a problem, the integral of the square root of 1 plus x dx. We are asked to evaluate, so what will be the value? Okay, so for those students who are planning to take up engineering, this is for you guys, okay? This will be the so-called familiarization of integral calculus. Okay, let's proceed with the first solution. For this morning, I will present two solutions. Solution number one, it will be by using the so-called power formula. Power formula is the integral of u to the n du. Okay? So by using formula number one, we will let u to be equal to the one inside, 1 plus x. The one inside the radical. So du will be dx plus 0, or du will just be simply dx, it is exact. So it seems the given integral is just under the form, it should be under the form the integral of 1 plus x raised to 1 half times dx. Okay, so the value of u inside is actually this one. And du, as per verification, is just simply dx, it is exact. So the given integral, the integral of 1 plus x dx, it should be equal to the integral by using the so-called power formula. This is the integral sign of u to the n du. And the formula on how to take the integral of the power formula is just simply u raised to n plus 1 over n plus 1 is plus c. So substituting values, okay, I will erase this one. Substituting values, the value of u is actually 1 plus x. So this should be 1 plus x raised to, the value of n is 1 half. So this is 1 half plus 1. All over 1 half plus 1 plus c. Okay, indefinite integral, we don't have the lower and upper limit. So simplifying this one, 1 half plus 1 is actually 3 halves. Okay, this is over 3 halves. Okay, but if we try to simplify, we will take the reciprocal of 3 halves. So what comes out for the coefficient will be 2/3 times the quantity 1 plus x raised to the 3 halves plus c. So this is the answer for the given integral. That is by using the power formula. And to bring out solution number 2, actually there is solution number 2. Or actually we could present solution 3, but for this morning I will just present 2 solutions. So you know the variations and how to solve problems. Okay, I will check my camera. Okay, solution number 2. For solution number 2, we will be using algebraic substitution. Okay, we let z, another variable, to be equal to the square root of 1 plus x. Squaring both sides, c squared should be equal to 1 plus x. Solving for x now will be z squared minus 1. Take the differential of both sides, dx will be 2z dz minus the differential of 1, which is 0, or dx will just be simply 2z dz. Therefore, the integral of the square root of 1 plus x times dx should be equal to the integral. Okay, we will place the new variable now. From our representation, the square root of 1 plus x will be z, so we will replace this 1 by z. Okay, and dx, as per our computation, is actually 2z dz, so this is times 2z dz. Proceeding with the integration, we bring out 2. It's a constant, right? So it will be 2. The integral of c squared z times z, loss of exponent. It should be same base, then add exponent. So it will be c squared dz. And again, this falls under the power formula. The value of u for this integral now will be z, du will be dz, so it is exact. So again, we still use the power formula. So this will now be 2, di ba? Then times c cube all over 3, close bracket, plus c. To bring back the original variable, we will replace z by the square root of 1 plus x. So what comes out will be, this 3 here goes out, so the total coefficient will be 2/3 times the value of z is actually the square root of 1 plus x to the third power plus c, or 2/3, okay? The square root of 1 plus x to the third power, okay, is actually 1 plus x raised to the 1/2, raise that again to the third power. So it should be 1 plus x, okay? We multiply 1/2 by 3, so this will become 3/2. So the final answer is actually 2/3 times the quantity 1 plus x raised to the 3/2 plus c. So as you can see it, the first solution is the same as the second, the first answer is the same as the second answer, even by using algebraic substitution. Okay, so for this morning, that's the two solutions by solving or evaluating the integral of the square root of 1 plus x dx. Okay, so for those who are taking up engineering or preparing to take up engineering, this is for you guys. If you want to subscribe to my channel is at youtube.com/@proofdavidj.de. And if you want to share it, please click share. Good morning from Los Angeles.